Hey, hello, and welcome once again to Gumzo's Cybersecurity Podcast. Today, I want us to discuss about the management of vulnerabilities and the whole issue of vulnerability archiving, management, and how are they classified and scored, right? And everything that relates, all the concepts that relate to vulnerability management. So once again, let's begin by defining what a vulnerability is. I know we have previously spoken about it, but it doesn't hurt to go through a concept again and define it so that we don't keep on mentioning vulnerabilities, but there's some of us who do not fully appreciate what a vulnerability is. We will mention that and give examples. So a vulnerability is a weakness or a flaw in either a system, a process, a hardware, or essentially um, those are the key elements that we would be looking vulnerabilities from. So again, we are talking of a software, hardware, or a process. So it's a flaw or a weakness in those four elements. And it's a flaw that can be exploited by an attacker to compromise the CIA triad of confidentiality, integrity, and availability. So, what does it uh, appear as? What is its nature? So it appears as a defect or a gap that could be used maliciously. Let's give examples. So a common example could be a buffer overflow in a program, such as, so these I'll give a fully fledged vulnerability, a real vulnerability, and take note of the naming convention. So this is a CVE 2017 0144. So this is the Windows SMB version 1 vulnerability that was used in WannaCry. Let's talk about another example of a vulnerability. A vulnerability could be a default password. It could be a misconfiguration. So assuming you have just installed a tool such as SSH for something like remote access. So at that point, the moment you use it, you have not changed the default port. You have not changed the default port. You have not even taken care of brute force attacks, multiple tries of authentication until the attacker gets the right password, the username password combination, right? So those are examples of vulnerabilities. So I gave an example of a real one, the CVE 2017-0144. And then I also said default passwords. Those are key vulnerabilities. And then misconfigurations. So the moment you bring on board a particular software that has a default password just to give you initial access for your administration, then you should, as fast as possible, change that at the earliest opportunity. So let's go to the issue of how are these vulnerabilities detected. So remember we talked about VAPT, vulnerability assessment and penetration testing. So that vulnerability assessment is what you're looking for. So essentially, vulnerabilities will be discovered through security assessments, code analysis, and penetration testing. So how are they categorized? Vulnerabilities are categorized under CVEs, or Common Vulnerabilities and Exposures, and CWEs. A CWE, as we will see in the process of our discussion later, is essentially the root cause of a key named vulnerability. So this is a CVE is a CWE is a common weakness enumeration, right? So let's go to an exploit. So we talked about a vulnerability being a flaw or a weakness that can be exploited by an attacker to sabotage CIA triad. What is an exploit? An exploit is an actual method or code or a sequence of commands that takes advantage of a vulnerability to perform unauthorized actions. What is the nature of an exploit? An exploit uh, takes the nature of weaponization of a vulnerability. So you take a vulnerability, study it, and now you apply techniques, tactics uh, to be able to take advantage of a system using that knowledge, right? So let's give examples of exploits. So an exploit could be a script that executes arbitrary code through a buffer overflow. It could be a malicious payload that leverages an SQL injection flow to exfiltrate data. And let's look at the types of. So number one, you have a POC or a proof of concept, which demonstrates the exploitation possibility of that particular exploit, right? What you remember, we've said this can be it's an actual method, code, or sequence of commands. So yes, you have said this is you have you have your vulnerability and you have this exploit, but you have to prove that it is an actual piece of operation that takes advantage of a vulnerability, right? So that is what we're calling a POC or proof of concept. Then we have a weaponized exploit. So this is a fully developed code used in attack. And when we are talking about the command and control using Metasploit framework, we will come across this concept readily well of weaponizing exploits, right, and delivering them as payloads to the target system. So we have two types of exploits. So we've said one is a proof of concept, which is a demonstration of the exploitability or exploitation possibility. And then we have a weaponized exploit, which is a fully developed code used in attacks. What is the typical outcome of these exploits? This is essentially unauthorized access, privilege escalation, or service disruption. Service disruption comes about when you're experiencing things like distributed denial of service attacks, denial of service, or even when inadvertently your drives are encrypted, right? And a ransom is asked for. So therefore, we say that is a ransomware. So anything that essentially does unauthorized access to information, alteration of records, privilege escalation, service disruption, that is the outcome of an exploit. As a hack because an exploit has been successful. That is what I can say. Let's talk about exposures, right? An exposure is a configuration or a state that directly causes a compromise. But that is not correct. It is a state that essentially will not cause a compromise, but increases the likelihood or impact of an exploitation. So that is an exposure. So it is that state that in itself does not directly cause a compromise, but increases the likelihood or impact of an exploitation. And we could give the nature of exposures. So this is a situation that will facilitate is an attack. So let's say you have open ports. You have ports that you do not use, but they are accessible. They can make your system to be accessible. Essentially, it's not a vulnerability, but it's an exposure, right? So, another examples that we could give could be publicly exposed admin interfaces. And when you're doing, in fact, we will do a couple of tests using open source tools that are available on Kali Linux. We'll try to look for these exposures and vulnerabilities. So that what we are talking here is you can actually see it's a possibility. It's something that can happen to you. You even probably you're getting advisories if you're a developer from GitHub, but you're ignoring these advisories of vulnerabilities, that your code is vulnerable, that you have a library that is not maintained and therefore not receiving security updates. That could actually be a key vulnerability. But we are talking about exposures now. So these are recipes for disasters. They increase the risk or impact or the likelihood that you will be exploited. So another example of an exposure is unencrypted sensitive data. So you're running data transfer service without proper encryption. I mean, you risk issues to do with man in the middle attacks, people listening to your conversation, tapping into your data. I mean, unsolicited or inadvertent data alteration through the wire. Then we could talk about detailed error messages revealing system information, and developers are guilty of this. So most of developers, when you're doing, if you use a framework, your framework will have a production state and a development or a development state. So the moment you have done your testing, everything is okay, and you're ready for go live, we're going to production, you should switch from developer mode to production state, such that even if there's an exception or an error, it does not give too much information about your code, about your infrastructure, about your database. So those are exposures. Now, how do you track exposures? They're also under a CVE system, the common vulnerability, the common vulnerability and exposures. So CVE will cover both vulnerabilities and exposures, though often they are differentiated from direct vulnerabilities, as we shall see. There's a difference clearly between a vulnerability and an exposure. Then let's give an analogy of so that we clearly understand what an exposure is. And we said it's a state that gives that increases the likelihood or the impact of exploitation. And exposure is be looked at it as leaving the door visible and labeled unlocked for an attacker. So remember, at the first stages of ethical hacking and even offensive operations is usually gathering intelligence, reconnaissance. So reconnaissance, that is where now you start fingerprinting, try fingerprinting, getting to know what kind of operating system are you running, what kind of protocol are you running, which ports could be open. So if you're using default ports, is for me is a huge thing. You should change. For example, the moment I'm configuring remote access for machines that I need to use, I will not use port 21 or port 22. So when I'm something like Open SSH, or something like SSH, I'll use a different port. I will go deep into the configurations and see the inherent security features it has. Before using fail to ban, what can you use? I'll even activate the uncomplicated firewall, yeah, that we are supposed to use in Linux, in Debian-based machines, just to ensure that whatever I'm doing, to some degree, even if I'm attacked, I raise the level of difficulty for an attacker. So the analogy of an exposure is leaving the door visible and labeled unlocked. So it doesn't mean it doesn't in itself break any security by itself, but it invites for serious impact on your system, security-wise. So we will transition to discussing now about the CVE system. So let's discuss about CVE. We said CVE, it is how it is the system that allows for categorization and classification of vulnerabilities and exploits. And exposures, not exploits. In fact, there's a DB for exploits, but now here we are talking about CVEs. So a common vulnerability exposure is a standardized identifier assigned to publicly known cybersecurity vulnerabilities. It is as simple as that. It is an identifier for publicly known cybersecurity vulnerabilities. So it serves as a unique reference number. So if you're into databases, you could look at it as a primary key for a record. But now the records you're dealing with here are vulnerabilities and exposures. So it will take the form of CVE, and then it will have an year and then a unique identifier. So this allows security professionals, software vendors, and organizations to share information consistently about specific vulnerabilities across different platforms. And so let's break it down. What is its purpose? The purpose is very simple. Ideally, is to provide a naming convention for vulnerabilities and exposures, enabling clear communication and tracking across global cybersecurity. Who manages, you may ask, who manages these CVE? So we have an organization called the MITRE Corporation that is supported by the US Department of Homeland Security, DHS, and Cybersecurity and Infrastructure Security, CISA. So let's look at the structure of the CVE. So we have the CVE prefix, as mentioned earlier when we were giving an example of the SMB version 1. So we have the CVE. This prefix CVE identifies it as part of the CVE system. Then we have the year that comes secondly. So we have CVE, a hyphen, then the year. So the year, this is the year the CVE identity was assigned and made public. And then we have the number, which is a sequential identifier. So you could say CVE-2025-12345. So that is a sequential. So let's give an example entry of a CVE will include. So it will have, number one, it will have a description. So this is a summary of the vulnerability. Then we will have the affected products. This could be software, this could be hardware impacted. Then there is the severity score. So when we talked about vulnerability management now, the essence of now classifying vulnerabilities comes in handy now when you start assigning weights or scoring vulnerabilities by severity. So the severity score is often linked to what is called CVSS, a Common Vulnerability Scoring System. It's a rating that ranges from 0 all the way to 0.0 all the way to 10, right? So 0 is none in terms of severity, and then 10 is critical. It's a scale of severity or criticality, if you want to say that. And then we have a reference. So a reference is links to advisories, patches, or related technical analysis of the vulnerability or exposure. So usage, CVEs are used CVEs are integrated into databases like the NVD or the National Vulnerability Database, where they are analyzed, scored, tracked for mitigation and risk management purposes. So a CVE will always be, we said they will analyze its severity, then it will be tracked for mitigation and risk management purposes. So that is the CVE system. So let's talk about the CWE, or the Common Weakness Enumeration. The Common Weakness Enumeration also is a standardized catalog of software and hardware weaknesses. That is the underlying flaw or error pattern that could lead to a vulnerability, such as the vulnerabilities that are tracked under the CVE system. Well, a CVE, the Common Vulnerability and Exposure, identifies specific instances of a vulnerability in a particular product. The CWE describes, in general terms, the type or class of programming or design error that causes that. So we could speak of an example be a broad such as SQL injection. And then under SQL injection, now you could have several vulnerabilities that are drawn from SQL injection as a class of software weaknesses in databases, right? So let's talk of, so in terms of, if we look at it from a hierarchical point of view, so before you get a vulnerability, you have a weakness. So we begin from a CWE as enumeration, and then it is cascaded down in specificity to CVE, or Common Vulnerability and Exposure. So those are two different databases, and we will look at them, the way they are maintained. Even from a MITRE point of view, we will have a look at those CWEs and give a scenario of how a CWE is cascaded from that level to a CW to E, and then to an actual exploit, right? So what is the purpose of a CWE? A CWE helps developers, security researchers, and organizations to understand and mitigate the root cause of vulnerabilities. So that, in fact, defines it all. That purpose, it helps security researchers, developers to understand and mitigate the root cause of vulnerabilities, and therefore improving software quality and code quality. So who are the maintainers of it? Again, the MITRE Corporation, in collaboration with the cybersecurity community, including government and industry partners, help in maintaining the CWE database. Let's look at the structure. Each CWE has a number, e.g. CWE, then dash, then the number, which is an integer. So, for example, it will have the CWE, the name, the CWE, the number, and a name. So, e.g., it could be cross-site scripting as a name. Then let's look at the entries that are included in a particular CWE. So it will include a description, same as a CVE, a description of the weakness. Then it will also have an example of how the manifestation looks like, and it will also have a potential consequence of that CVE, and then it will have mitigation strategy also, if there are many. Then what's the relationship between the CWE and CVE? So a CVE describes the specific vulnerability in a particular product, could be a software or hardware, and we shall see in our examples. Then a CWE explains the kind of error, e.g. improper, or the kind of error or mistake, e.g. improper input validation or sanitization, and that the CVE possible, right? So, for example, we have a CVE, a particular describes a real vulnerability in a web application, and then we could have, in the same breath, we could have a CWE that explains it caused the root cause of that vulnerability is improper, let's say, neutralization or sanitization of input during web page generation, right? So CVE describes a real vulnerability, then CWE explains the root cause of that vulnerability. So, what are the common usages of CWEs? These are used as foundations in various elements. So they can be used as foundations in secure coding guidelines. They can be used as foundations in static and dynamic code analysis, also security training programs, then vulnerability classification, e.g., CVSS, environmental metrics. So that in general is, and probably in deep details, that is how we the life cycle classification and the management of vulnerabilities. You see, they come from common weakness enumeration, and you to specific vulnerabilities. Let's talk about tooling. Faraday, which is an open source tool that can be used for vulnerability management. Faraday in itself, they from their website describe it as a tool that normalizes, tracks, and identifies assets, vulnerabilities, data from over 90 different security tools. And so that tells you, if it normalizes and tracks and identifies assets and vulnerabilities, then it has to have APIs that allow for integration. So in our open source podcast, that is a tool we will look at, dissect it, even install it, and try to look at the kind of integrations that are available. We able to do automations using N8, 8 and 8, the open source automation tool. So are we able to also integrate tools like GitHub, try to pull in vulnerabilities from your code bases? We will try to do that and see how we can vulnerability management for developers, for people running networking hardware. So let's tune in on the next episode of Gumzo Open Source podcast, and we will mention the kind of tool we are showcasing. So this will be a cybersecurity related tool for vulnerability management. We will highlight it. We will walk you through it. How do you add a vulnerability? How do you do automation? Is it possible? How do you run it? Can you run it on Docker, or do you have to install it and provision for everything from the ground up? Does it have a command line interface? Those are things that we will look out for. Or is it just a graphical user interface? So those are the things that we'll be looking at. So we have said the tooling of choice that we have found that is most efficient or easy to put your hands on in a security context is Faraday. So you can look it up before our next conversation. We'll leave a link in our show notes. Thank you for this. We appreciate it. Till next time, keep safe.